Today we'll be working on graphing quadratic functions in standard form. Now the equation is y equals ax to the power 2 plus bx plus c, where a is the coefficient of x to the power 2, b is the coefficient of x, and c is the constant that's by itself. It's always important to determine what a, b, and c are before you can start solving everything else. Now by looking at the equation, you should be able to tell a couple of things right away. You should tell whether the graph is opening upward or downward. If a is positive, then your graph is opening upward, and the vertex will be a minimum. If a is negative, then your graph is going to be opening downward, and the vertex would be a maximum. You should also be able to tell what the y-intercept is. The y-intercept is the constant that's by itself, and that would be your y-intercept. Now to find your axis of symmetry, that's going to require some algebraic work. You have to set x equals negative b over 2a, find what that is, and that's going to be the axis of symmetry. Now remember, the axis of symmetry is going to be that vertical line that cuts your parabola in half and goes through the vertex. So the axis of symmetry will give you also the x of the vertex. Now to find the y of the vertex, you plug that number back into the equation and you can find the y of the vertex. Now let's go ahead and move on to our first example. It would be beneficial for you if you can tell what a, b, and c even before you can find the other things. So let's start with a. A is going to be the coefficient of x to the power 2. B is going to be the coefficient of x, and c is going to be the constant that's by itself. Now from the equation I can tell what the domain is, always. Domain is always going to be from negative infinity to infinity. I also can tell what the y-intercept is. It's going to be having an x of 0. It's going to be the constant that's by itself. We can directly start by plotting that. Now, the vertex is something we need to solve for. Now the axis of symmetry, we can use the rule to find that. The rule is x equals negative b over 2a. So in this case, let me write this better. So x equals negative b over 2a. So negative b, which is a negative 2, over 2 times a, which is a negative 1. Now remember, negative times a negative is a positive, and 2 times negative 1 is a negative 2. 2 divided by negative 2 is a negative 1. So my vertical axis of symmetry is going to be x equals negative 1. So let's go ahead and graph that. It's going to be the vertical line going through x equals negative 1. Now remember, the vertex will be on that line. Now let's go back to the vertex. The vertex will have the x of a negative 1. Now to find the y of the vertex, you need to plug that value into the whole equation. So y is going to be equal negative 1 to the power 2 minus 2 times negative 1 plus 8. Now let's do this together. Negative 1 to the power 2 is just a 1. Negative 2 times negative 1, that's a positive 2. Copy the positive 8. 8 plus 2 is a 10, minus 1 is a 9. So my vertex is going to be negative 1, 9. Now let's plot that point, negative 1, 9. And you will see that to find the x-intercepts, I will have to graph my function, and since the a in this case is a negative 1, it means I have to go down. So that's going to be an upside down graph. Since a is 1, then the pattern is going to be 1, 3, 5. So I go down 1 over 1, down 1, or down 3 over 1, and then down 5 over 1, then down 7 over 1. So the pattern is all the odd numbers, 1, 3, 5, 7, and so on. But I'm going to stick to the 7 since the other points will not fit in my graph. So that's going to be my parabola, an upside down parabola, reflected over the x-axis, as you can see, since a is negative. Now the x-intercept is where the graph touches the x-axis. In this case, I have two of them. I have a 2 and I have 1, 2, 3, 4, so negative 4. So it's going to be 2, 0, and negative 4, 0. These are my two x-intercepts. My roots will be then 2 and negative 4. Now, we talked about domain. Domain is from negative infinity to infinity. The range, however, is from bottom to top. So that's going to be from negative infinity all the way up to the y of the vertex, which is a 9. And that's how you do standard form. Okay? Now let's go ahead to our second example, which is this one over here. Okay, so let's go ahead and start. Remember, to find the axis of symmetry and the vertex, you need to be aware of the a, b, and c. A in this case is 2, the coefficient of x to the power 2. B is 8, which is the coefficient of x, and c is 6. Now my y-intercept is going to be my constant, because if I plug in a 0 for the x, 2 times 0 is a 0, 8 times 0 is a 0, so all is gone. The only thing that will be left is going to be the 6, so the y-intercept is going to be 6. Let's plot that. Okay. Now to find the axis of symmetry, which is always going to be the x of the vertex, I need to apply the rule x equals negative b over 2a. Now why negative b over 2a? We will discuss this in lesson 3-4, which is changing to vertex form. But for now, let's just memorize that x equals negative b over 2a, but it will make sense why later on. So negative 8 over 2 times 2, which is a 4. So negative 8 divided by a 4 is going to be a 2. And negative 2. Now, x equals negative 2 is going to be the axis of symmetry. So let's go ahead, move over, and let's graph this line, x equals negative 2. So remember, the vertex is going to be on this line. Now let's go back and let's try to find the vertex. Now to find the vertex, you know that the x is going to be the same as the axis of symmetry. The y is going to be something that you need to calculate for, or to solve for. So y equals 2 times negative 2 to the power 2 plus 8 times negative 2 plus 6. Now negative 2 to the power 2 is a 4. 8 times negative 2 is a negative 16 plus 6. 2 times 4 is an 8 minus 16 plus 6. So that's going to be a negative 2. So the y, or the vertex, is going to be negative 2 comma negative 2. Now let's plot that point, and it should be on the axis of symmetry. Okay, now let's apply the pattern to continue our parabola. The pattern is usually 1, 3, 5. If the a is 1, since a is 2, you have to multiply by 2, so it would be 2, 6, 10. And I have to count upward since a is positive. So I'm going to go up 2 over 1. I'm going to do up 6 over 1. So as you can see, I can tell that I'm correct since my points now are coinciding with the y-intercept. So my pattern is correct. So there's always a couple of methods or ways for you to double check your work. Now let's find the x-intercepts from the graph. So far the x-intercepts have been pretty points that I can see on my graph. So it's negative 1 and 1, 2, 3, 4 and negative 4. So my x-intercepts are going to be negative 1, 0 and negative 4, comma 0. These are my two x-intercepts. The domain is going to be from negative infinity to infinity always, since this is going to be continuing on forever on the left and the right. The range is going to be from the bottom, which is the y of the vertex, negative 2, all the way to plus infinity. And that's going to be the range. Now, that's everything for this lesson. Please make sure that you go to the practice sheet and practice and check the key online to make sure that you get this lesson.